Hello everyone, Foamy Guy here. In this video, I'm going to walk you through the process of adding type hints to a CircuitPython library. So right now I'm looking at the VC0706 library. I think this is for a camera device, TTL camera module. The specific library and the specific device are not super important. The main thing that I'm trying to show in this video is the process of getting the type information in. This is something that we have been, making an effort towards in the CircuitPython libraries lately. We always want to get new folks involved. This is one of the easiest things you can do without even a whole lot of experience. So we have a bunch of these issues marked good first issue, and I want to record this video to show the process. That way folks in the future can look through and see how I go about this. So with that, let's get going. So I already have the library downloaded. I cloned it. I've even got my fork ready to go. If you need help with any of that stuff, there are other resources out there for you. So I'm going to kind of just take it from the beginning where I already have that stuff done. But if you do need help with that, feel free to reach out on Discord or look around. There's learn guides and different things that'll get that part of it for you. So I've got it downloaded, opened up into PyCharm, and basically when we are adding the type hints to these libraries, we want to basically add them to all of the function arguments and all of the function returns. So I'm scrolling down here and I'm finding this right here, the init function. This is the first function called by this particular class. So this is where we're going to start adding our type hints. The first argument is UART. I happen to know the type for this is going to be, I believe it is busio.uart, I believe is the type. And we will need to import busio, and I will also go ahead and do the try except block. Import typing I'll do as the first one. So we use this as a way to basically save RAM on the microcontrollers. When you are using code on your PC, when you're editing libraries, when you're building code on your PC, this is when type hints are most beneficial to you. The microcontroller actually ignores them. So, it doesn't need the type hints to run. It's not going to be bothered if they're not there. And so what we do is we always import typing as the first import inside of a try block. We then catch, except the import error that will get raised if this import fails, which it will on microcontrollers, because on CircuitPython, we don't have the typing module built in. This is a concept in CPython, but we don't have one in CircuitPython. So this would raise the error. We are going to catch the error right here. We're just going to ignore it. So we pass. We don't have anything special to do. And then I'll also, while I'm here, import busio. And now the thing is, we put the busio import, let's get that fixed, import. All right, so we got the busio import now, and the important thing is that we put this after the typing import. We always want to import typing or import something from typing. We always want to do that as the first import. That way, when we're on the microcontroller, this one will raise the error, and it will not actually import the rest of the ones that we put inside of this try block underneath typing here, which is perfect because that means we will save a little bit of RAM. Since this won't actually get imported, we won't use the RAM for it when it's running on the microcontroller, again, when it wouldn't be helpful anyway. I am going to take a look into the busio docs just to make sure that this is the right place, or the right type, I should say. So let me do that. Docs, CircuitPython docs, and I'm just going to double check on busio because I believe this has a UART type, just like it does I2C and SPI. Although I am more familiar with those two. The other place we could check this is actually on a device, which wouldn't be a bad idea at all. Let me, in fact, plug in a device here, and we'll jump into the REPL in a few minutes as well. Let's see, where is the board going? Okay, right there. Oops, this is a bigger one here. Okay, got that plugged in, so we'll use that here in a bit. So on busio, we have I2C class. We have SPI class, SPI. And we have UART class. This is the one that our particular driver is using. So busio.uart, this is the class that we want for the UART function. So we've got that coded in. Now this star, this is kind of like a wildcard argument. This one really can be anything. And I'm not entirely sure, I'm not super familiar with this driver. I'm not entirely sure why it needs the star argument. Let's look in the example. Yeah, not much going on there when it gets actually created. So the star one is a bit of a weird case. Ordinarily, we would ideally not have to have this wildcard import like this, but it may be necessary in this case. And so what we'll do is we'll code it with the any, which actually does come from typing. So I'll switch my import here to say from typing import any. And you know, whether you do import typing or from typing import any, that part doesn't matter. The thing that changes is how you can refer to this down here. But like, you know, one is not better over the other. And really the important thing is just to make sure that the first import, whatever it is, it's either import typing or it's like from typing. Making sure to do that as the first one. Formal parameter name expected. I think maybe this one is not going to work, actually. I'm going to leave the star out. I'll have to read up on the star, maybe. Not very many libraries do have this star wildcard argument, so luckily this is not something that you probably will run into too much. I was thinking any would be the right type, but it didn't seem to like that. So I'll leave it off for now. Buffer size. So this one right away, we can tell it has a default argument, which is an integer, 100 specifically. So we know right away this one is an int. So this is actually pretty easy. We can just fill in int. I will just run the code formatter in PyCharm. Of course, we're going to run black on this as well, which will end up formatting the code. So that's another way to get that done. So we've got UART, we've got buffer size, and then the only other argument is any. Which I'm going to skip for now, this wildcard. I think this may be the proper thing, in fact. It may just not need one, but I will have to look into it. So those are the arguments. The other thing we want to do is the return types. The way we type for returns is we make this little arrow after the parentheses in the function, and then we put our return type here. This function, init function, does not have any return statement. Therefore, it's going to be returning the type of none. It will implicitly return none when Python, you know, calls this function, when some code calls this function. So next up, we can go down to the version function. This one is a property, but we still type it the same way. It does not have any arguments, so we don't have any work to do there. So we do still want to code the return type. In this case, we can tell right away again, this is saying return, and then it's calling string, and then it's giving it this thing inside of here. So we know that whatever this thing is returning, it's going to be a string, because that's what this string function right here creates. So here we can say return type is string. Baud rate, next one. So this one also has no arguments, and this is returning, let's see, self._.uart.baud rate. So my guess is that this will be an int, but let's take a look at the, let me close that one. Let's take a look at the UART docs here. So parameters, baud rate is listed as an int right here. Baud rate, the property, is also listed as an int right here. And since UART is the object we have, we got passed a busio UART inside this argument here, and then we set it inside of this self._UART. So we know that's what type of object we're working with. It's accessing baud rate. We just saw in the docs that baud rate is an int. So we'll code our return type for this one, put an int. Next up, baud rate setter. So this one does take a argument, so we want to code that. And it looks like this is also going to be int, which makes sense because, you know, we get an int when we access the baud rate. It would make sense to set it as an int as well. But some other evidence is that this value that's getting passed in, we have it in this if statement here, where it's checking on each of these, and it's saying, is it equal to 9600 or 19200 or all of these, right? And these, all the things it's comparing it to are ints. So we know, this code is expecting this thing to be an int, presumably expecting it to be one of these ints in the if statement. We'll code this one, int. All right. And we can do the return type. This one has no return statement, therefore it is return none. Image size, let's see. This one, again, no arguments. And this one is a little bit trickier. It's returning this underscore buffer 5. So let's look in the docstring here for a bit of information. This says get the current image size. It will return a value of image size 640 by 480, 320 by 240, or 1600 by 120. Oh, not 1600, but 160, of course. So this tells me there are constants declared further up at the top of this file with these names, and this function is going to return one of those constants. So what we're going to do is Control F. We're going to find where it is declared, and they are right here. These are declared as constants, and they are also ints. These ints happen to be written in hexadecimal, but they are ints nonetheless. So back down here on image size, we're going to code our return type, which we now know is going to be an int. Image size setter. So in this case, we are setting one of these three constant values. That's what the argument we are expecting is. We know already that those are ints. So we can code the type for our argument. And this one, interestingly, is a setter, but does return, which is actually somewhat atypical. Usually when you have a setter, it doesn't return anything, and thus it ends up returning none. In this case, though, it's returning, and it's calling self._run command, and then it's going to end up returning whatever run command returns. So you call image size calls run command, whatever run command returns, then gets returned by image size. Since it is a property setter, I'm not actually sure how you access it. Maybe you have to call the function specifically instead of use the setter. That part I'm not sure about. But what we can do is maybe look into run command a little bit more. And I think there is a hint in one of these other doc strings. In fact, it's this one right here. So take picture. This says tell the camera to take a picture, returns true if successful. So true is a Boolean type. And if we look at the code inside of here, this is also just calling self.run command. It's passing different stuff here, of course, so it's not the exact same thing as what's going on here because it has different input, but the function it's calling is the same, return command. And this one says that it returns true if successful. So that leads me to believe that the run command function basically will return true or false. True if it was successful, false if it was not successful. And since we are just grabbing whatever run command returns and returning it from image size here, I think it is pretty safe to say that we will also be returning that same Boolean that the take picture one from down below has. So our return type here, bool, is short for Boolean. Okay, we got this one argument return, frame length. This one is another property, has no arguments, it returns frame length. Frame length, return the length in bytes of the currently capture frame. I guess maybe captured. So we'll fix that up while we're here. So, while you're doing these typing information, you can make other changes as well, especially typos and things. We can always fix those if we run across them. So this one is returning the length in bytes. So length in bytes sounds like it should be an int. When we express the length of a number of bytes, generally that is done with an int. Say this one returns an int. Okay. Take picture. Okay, so yep, this one is the one we looked at before, take picture. So we know this one is going to be returning a Boolean. It's calling run command, just giving back whatever value that gets. And this tells us here that it'll be true if it's successful. So we can assume it should be false if it was not successful. Resume video. This is another one, just calling run command. So this one looks the same. Let's do return Boolean. Read picture into. Okay, so this one has an argument called buff. Read the next bytes of a frame/picture data into the provided buffer. Returns the number of bytes written to the buffer. Okay. Hey. Okay, so we know that this returns the number of bytes written, which will be an int. So we can put in our return type int. And now this one's a little trickier, the buff argument. So read the next bytes of a frame/picture data into the provided buffer. So I think that buffer is going to be maybe bytes, but let's see if we can find some other clues as to what this will be. So what I'm going to look for is usages of this function. I'm going to search through the examples and the rest of this code file, and I'm going to try to find usages that are calling this function. In PyCharm, this works by just control clicking on the function, and it pops up a list of them here. If you're not using PyCharm, no problem. You can just copy the name of the function and then do like a control F to find it, and click over to the examples and control F to find it there as well. And indeed, we see a usage of it inside the simple test example. This calls read picture into, and it passes in copy buffer. And copy buffer right here is created as a byte array. So we know the type of this is going to be a byte array. So we can go back into here and code byte array as the type for buffer. So we got our argument, we got our return. That's all we need. On to the next one, motion detected. So this one takes no arguments, and it looks like it's going to be returning either true or false. So that's a Boolean. So we'll go return type Boolean. Get motion detect. This is another one that is running a command and then returning the result. Query the gesture detection status. So this one is going to return again true or false, because that's what we saw earlier run command does. So return type Boolean. Set motion detect. Args. I didn't update this, did I? Git fetch. Yeah, I didn't update this. So I happen to know that this argument named args got changed in the latest version of this library. And I thought I had updated before I started this video, but it turned out actually I didn't. I was one version behind. But now I've just gone ahead and done the git pull, essentially, which updated it. And PyCharm has a nifty feature which will allow it to kind of keep all of my changes, even though they're not committed yet, and still pull in the new changes, as long as there's no conflicts, which in this case there weren't. So now we're actually ready to go again. We're up to date. We have the latest version enabled. This is a Boolean. It says in the doc strings right here. Boolean. And then this one is also returning run command. So we know that's going to also return the Boolean. It's that true or false. True if it was successful, false if it was not. Okay, so here is actually our run command. So we actually know this one. We can see here as well that it returns the Booleans. So that matches what we've been doing. So let's put our return type Boolean. And now let's take a look at our arguments. Well, flush has a default value of true, so we know that one's a Boolean. So let's fill that one in. Resp_len, I'm guessing this is response length. Response length, so this would likely be an int. Let's find a place where this actually gets called, though. For instance, just right up here, it's calling run command. The first argument is this, that would be command. The next argument is args, And then response length would be the next argument, which is this 5 right here. 5 is indeed an int. We can fill that one in. So you can kind of see it takes like a little bit of detective work to find the right types sometimes. Some are easier than others. Sometimes you can find them from the doc string. Sometimes you can find them from the code usage, like inside the function definitions. Sometimes you can find them in the examples based on what's actually getting passed in. You kind of have to, put your detective hat on a little bit and search around for clues as to what the types are. The next one is args, and we see, in fact, right here, this one is being called and it's passing in bytes. It's calling bytes and then passing it these two values. So this is going to generate a bytes object. So we know args will be bytes. And then that leaves command. So command, it's passing in this variable. So what we can do is we can go and look at where this variable was declared, which is up here. Com motion control, this one is another constant. And it is 37 in hex, which is also an int. Just because it's in hex does not change the fact that it is an int. So we'll head back down, and we now know command will also be an int. Now we've got all of our arguments, is that right? Command, args, response length, flush, and returns a Boolean. That one's the return. So yep, we're looking good there. Next is send command. So this one, args, is defaulted to none. So this one's going to be optional, which we haven't had a chance to see one of those yet. The way you code that is optional, and then square brackets, and then the type. And this type, args, I assume it's going to be the same as the args was up here, which is bytes. Also, I see I skipped a couple here. I'll hit those after this. Optional bytes, I think, is what this one's going to be. This still has red underline because we need to add the import for it. So I'm going to head back up here. And this is also actually part of typing, so I'll just switch this. We didn't end up using any, so I'll say from typing import optional. Be able to get that. I'll take care of our error underline there. So now we got args in. Let's see, the other thing we could do to check on this maybe is here, it's passing args into uart.write. So we could further verify this by looking back in the docs for uart, find the write function, right? Which actually is one of our special types. So this is typed as a writable buffer, which is a special type that we added to CircuitPython typing. I think there's something analogous to this in CPython typing, in regular Python. But we have this library specifically for working with CircuitPython types, and we actually have writable buffer on it. So instead of bytes, that's actually going to be what we want to do. It functions a lot like bytes, but this is just declared more specifically somewhere all of the different types of things that this is allowed to be inside this CircuitPython typing argument, library. So actually we'll change bytes to the same thing we saw there, CircuitPython typing.writable buffer. This one will need to get imported, and we're going to put that again under typing. Import CircuitPython typing. Okay. What is this one? It says something not found, maybe. I may not have the most up-to-date version. Let's go pip install upgrade CircuitPython typing. Expect I probably have a, let's see, not find. Oh, because we need the actual name of the pip listing. I guess is probably going to be, whoops. Typing here. Herman already satisfied. Yeah, there we go, 1.3, so we were behind by a little bit. So probably this will allow PyCharm to recognize this writable buffer. Even if PyCharm doesn't recognize it, that's all right. We can still continue on. I think I may have to save, and it also may take it a minute to catch up. So that may disappear here in a moment. If not, that's okay, though. We know, based on what we found here, we pass CircuitPython typing writable buffer to this, and we are taking that args right here and passing it in. So we know it's that same type. Even if my PyCharm can't figure it out right now, based on what I have installed, we do know that it's the right type. And of course, it's optional because it can be none as well. Which is what the default value is. We have command here, which we saw before. This was an int. This is basically one of the commands, like we saw a bunch of them as constants up here. A bunch of these com commands. Okay, so we can do the return type. Oh, well, okay, and this one has no return, so that's going to be returning none. Using white space. Make that happier. Okay, and then I accidentally skipped a couple here, so let's do these last two, and then I'll wrap it up after that. I think we got everything else done here. This is probably like a medium to, small to medium library. I think there were about a dozen or so functions in it. So not, more than a few. I wanted to pick one that had enough that we could get a good examples of a bunch of different types. But I didn't want to do a massive one either and make the video like hours and hours long or anything. So I kind of picked a medium-sized one to try to get a good sampling of different stuff. So let's see what we have here. Memory view. So result. So num bytes, this is going to be an int. It's being used as an int as part of a slice here. Also, the name is a bit of a hint, right? Num bytes implies that it's the number of bytes, which we know from before. This is going to be an int. Result, this one is a little tougher. So memory view, so we're calling memory view, we're passing it result, and then we are accessing 0 to number bytes slice from the memory view, and then that's what we are passing to read into. So let's start with what does read into take. Read into, this is a writable buffer as well. And so I think result here is also going to be a writable buffer. This one I'm less sure of, though, truthfully. So read into, let's look at memory view. What does this say that it takes? Is this in the CircuitPython docs? Memory view. Built-ins memory view class. We want the function, though. This only, oh no, this appears twice. Exception, memory error. Built-in class. I'm actually less sure on this one. I'm going to do a little bit more research here. Python memory view. Let's see if anything gets up from this. Memory view before learning about this. Really what I want is the doc strings, truthfully. If I could get the doc strings, this will... Without needing to copy it first. Review method. Object. Of the given object. Buffer protocol. Okay, so buffer protocol, this is actually, I believe it's going to be a readable buffer. The memory view is wrapping around the readable buffer and giving access to that internal data that's inside of that readable buffer. I believe that's our type. We are we are using a writable buffer down here because that's what gets passed like we saw before. This one, I believe, though, is a readable buffer. So this, it's not optional, this one. It doesn't have equals none, so presumably you're not supposed to pass none to this. And then we will go CircuitPython typing readable buffer. Okay. Verify response. So this one takes a command, which we saw before. All those commands, those were ints. We got a couple of returns here as well. This returns whatever comes from read into. So let's go back to the UART docs and find read into again. Read into. This returns an optional int. It returns the number of bytes read and stored into buffer, and it's optional, so that means it could be none instead. This one we know we're calling read into here. We're returning it from read response. We saw it just there. Optional int. Optional int. Okay. Now this one is, the stuff it's returning is inside of parentheses, which, oh no, but there's no commas, so this is not a tuple. This is basically a logical expression. It says, you know, is this value equal to this, 76? And is this thing equal to this? And is this thing equal to this? And is this thing equal to this? When you make a big, long logical expression like that, all those ands ultimately boil down to a Boolean. Either all these things are true or not all of these things are true. So true and false are our possible values here, which is a Boolean type. So verify response is going to be returning a Boolean. All right, so we got command. So basically, I'm just going to double check everything here. I got the return type of none on this one. We got all the arguments taken care of, right? Args. Command, yep, looking good there. Command int, return, yep, looking good. Result, num bytes, and return. Command args, response length flush, and return. Enabled, and return, return, return. Just double checking all of them here. Buffer, byte array, yep, return is good there. No arguments, got the return, got the return. Again, no arguments. Got the return, yep. Size, return Boolean, no arguments, return int for baud rate, return, no arguments, return, no arguments, return, and that gets us back up to init, and we had UART, the ini we left open, buffer size int, and return none. So we're looking pretty good here. So at this point, we are ready to make a PR from this. So the very last thing I'll show you as part of this video is that we do want to run pre-commit on this code before we actually push it and make a PR from it. I won't go through the process of actually creating the PR right now. I do want to kind of keep this video as short as I can, and we're already probably running fairly long here. So I'll stop it here. If you do need help making a PR, you can definitely reach out on Discord. And if folks would be interested in seeing a video that covers the process of making a PR, let me know as well down in the comments, or again, reach out on Discord. I'd be happy to make that video if folks are interested in it. But I think here I will call it good. We got this VC0706 library. We got it all typed. We're passing pre-commit now. We don't have any failures, so we're ready to push this, make a pull request from it. So thank you everybody for watching. Thank you especially to anyone who's watching that does help us work on the typing information for the CircuitPython libraries. I hope this video was helpful, and I will see you next time. Thanks.